In the realm of machine learning, the train-test split is not just a concept, it's a cornerstone. It is the backbone of model validation, the gatekeeper ensuring that our predictive models can generalize beyond the data they were trained on. Imagine you've built a model to predict house prices. You feed it data, it learns patterns, and voila, it starts predicting prices. But wait, how can you be sure that these predictions hold water? How can you be sure that your model isn't just memorizing data and regurgitating it? That's where the train-test split comes into play. The train-test split is a simple yet powerful technique. It involves splitting your dataset into two parts, a training set and a test set. The training set is what you use to teach your model. It's the textbook your model learns from. The test set, on the other hand, is the exam paper. It's the unseen data that your model needs to predict. The process is straightforward. You first import your dataset. You then carve it up into features and target variables. The features are the characteristics you think will influence your target variable, which in this case is the price of a house. Once you've separated features and target variables, you perform the train-test split. You're essentially dividing your dataset into two parts. One part goes to training your model and the other part is set aside for testing. But what's the ideal split ratio? Well, there isn't a one-size-fits-all answer. It depends on your dataset and the problem you're trying to solve. However, a common practice is to use 80% of the data for training and the remaining 20% for testing. One critical aspect to remember is the use of the random_state parameter. This allows you to reproduce the same train-test split results, offering consistency in your experiments. After performing the split, you can then train your model on the training set and evaluate its performance on the test set. The performance on the test set gives you an idea of how well your model can generalize to new, unseen data. In essence, the train-test split is the litmus test for your model's real-world applicability. It ensures your model is not just an expert on seen data, but a real predictor of the unknown. It is the difference between a model that merely memorizes and a model that truly learns. And that in the grand scheme of machine learning is what really matters.